My name is Gajraj, and I'm having around 15 years experience in Innovia PLM. I started working as a developer, so I know lots of issues as a developer when I was facing when we are rather than developer when we are working as a maintenance support, then the issues and challenges are different. But recently, for last few years, I'm working more as a DevOps consultant, uh, even before TECHNIA. So that's why we understand that what kind of issues we are having as a developer, as a maintenance. So the solution we found that we are proceeding with some standard practices which we are having across the market, even outside of the PLM world. So and that's why I'm here to explain some more practices related to DevOps. So first question comes, why DevOps? We know that we have explained that what are the benefit of PLM, that time to the market for any product, the quality of the product, and with this implementation of PLM, we can have the better collaboration kind of thing. Similarly, if we are implementing DevOps, we will have the faster delivery of the future. We will have the less complexity. We will have a more productive team, because we know that when we are working in the system, we have different teams, and all those teams have to collaborate with each other. So that this DevOps practice help us to have a better collaboration, and that's how we get more time to for the innovation, because we have to spend less time in maintenance and less time in issue fixing. And last but not least, that with the help of these practices, we implement communication and collaboration within the different teams. And this is what we have just seen before some time, that when we are implementing PLM, it gives us shorter time to market, reduce the compliances, it increases the productivity, and it drives innovation. And of course, that improved collaboration. Basically, there is not any such comparison between DevOps and PLM, but all I'm trying to explain that if we are implementing PLM, it helps us to have a better product in the market. Similarly, if we implement DevOps, it helps us to have a better software within our organization. So I'll talk a bit about DevOps tools and principles. So the first principle is automation. We know that nowadays we talk more about automation. And why we want to do automation? Because we want to have the continuous improvement. And continuous improvement, we follow this continuous integration and continuous delivery concept, which help us to get continuous improvement in our software. And how we do it? With a lot of iteration and collaboration. So iteration of the same thing, we keep doing the same thing. That means, let's say we have some user requirements and we want to implement, or we want to go live to our production system. So sometime it takes 6 months to have those features in a real system. But if we reduce the cycle to 1 month, to 2 weeks, to 1 week, then the benefit is that we will do it more iteration, and then we will find that what kind of issues we are occurring, and we can resolve those kind of issues faster, and that's how we can improve the quality of our software. Here I'm just showing the life cycle of this DevOps, which is pretty much similar to the life cycle of software, and lot of tools which we can use. It's not necessary that we have to use all the tools, but it has a capability or to have kind of integration or kind of use a different tools in a different phases of a DevOps cycle. So let's say we can start with planning. First, planning is just getting some requirement from the business, and then we write our code accordingly. So planning we can have in our Jira, code we can have in our Git or Jira. Then for build tool, we can use the Gradle or Maven. Then we do some testing around it using some automated Selenium and JUnits. then automated deployment using Jenkins or CodeShip. Then we have operation cycle, monitor cycle, and again planning cycle. So this is how we work in agile phase. So we get our requirement frequently, we release our requirement frequently, and we go through this entire cycle. So to have this kind of system, we have to more focus on automation and continuous improvement. Now, how we are in this slide, if you see that we are more having like automation and continuous integration, continuous delivery. This is what I'm going to talk more about. Continuous integration and continuous delivery with Jenkins. First thing, I'll just explain that what is continuous integration, continuous delivery. As we know that our developer, they work on daily basis. Okay, so it may be possible in 2 days or 3 days, they just finish their small feature which they want to release in that cycle. So they just commit the code. The question is, as a developer, or we have around 10%, and every day we are just committing few code in the system or in a repository or in a code base, then there should be some automated way to run that, to identify that whether the code which you are pushing to this repository, it's not breaking the functionality, it's working correctly, and it's supposed to do what it is supposed to do, it's doing the right thing. So we can have the kind of automation functional testing, we can have a automated code testing, and when we have this everything together, so that means you are just integrating your code and validating it. So that concept is called continuous integration, and that is more important for when we want to have a quality software development. So let's say we don't want to have a situation when somebody has pushed the code, and during our testing phase, the system is not working, or system is not responding because there was some issue in the development time itself. So that should have been tested earlier. So the concept is, as soon as a developer is committing the code, it will automatically trigger a mechanism which will build the code, which will deploy the code, and which will run some kind of basic test on that application, that after the development, after the developer is merging the code, it's not breaking the system functionality. Here of course, there could be some other option also to have this kind of implementation, but what solution we are having or we are using inside TECHNIA, we are using Jenkins as a CI server. So in this diagram, you could see that the developer is committing the code to repository, then it is communicating with the Jenkins CI server. We are using some TECHNIA tools like schema tools, Gradle, SonarQube, Artifactory. We are using some other tools like Selenium, JUnit. We can build it, we can make an artifact, means copy, that it is ready to deploy in different environment. It could be deployed in dev, test, and production. And we can also integrate a notification system like Microsoft Teams. So let's say if someone wants to get notified, okay, if that is available in dev environment or test environment, so that I will get notification, so that I can do my part, I can do my testing. So we can have notification system also. So this entire thing is called continuous integration. And when we have the complete life cycle to deploy in dev, test, production, that is continuous delivery. So this is how we are using here Jenkins to implement this concept, which is very much common if we talk about outside of PLM. Now, I'll just focus a bit more towards PLM system rather than talking on the generic entire DevOps. So what are the challenges we are facing? First thing, what we face more, the main problematic is that the build or deploy tools which comes with 3DX platform, that is not having capability to integrate with a different external tools. It works pretty well when we are having OTB setups or out-of-the-box system, the standard SL system. But once we start making some different changes or different way of implementation, then we face some issue with this tool. Second, the database installation, like Susanna was showing in the previous slide. The in Dassault, in this 3ds platform system, we write our code in JPO, or that is in database, rather than on having files. That is second challenge. Third challenge is that installing. See, whenever we are making a configuration change, it's not only in the file, it's also in the database. So whenever we are writing any configuration or whenever we are doing some customization, we have to change something in the database as well. So just implementing that is also a bit difficult if we want to have some standard tools like MQ or something. So here what we can do is we are having the schema tools, which we can use for this installing this database related configuration. Next challenge, difficult to have symmetric setup in different environments. So that these issues were related to code side. Now, if you talk about the maintainability or configuration side, then we have different challenges like the dev environment, test environment, and the developer environment. Those are different. So something is working for a developer machine, but it's not working in dev. Something is working in dev, but it's not working in production or test environment. So how to resolve that issue? One simple approach is that we should have symmetrically all the environments. But if we are doing that thing manually, it's very difficult to have symmetric environment for developer, for your development environment or test environment or production environment. So that's why we should use this automation concept to implement or to set up this different environments. And this is what is one more challenge, and we will talk about the solution of that also. The next is difficulties in fix spec upgrade. Like Susanna was saying, that upgradability is one more key aspect. We should keep upgrading our system, and mostly we get some kind of hot fix or some fixes, some issues which are in the product. We got a solution, okay, then this version will fix this solution. But again, challenge is to run that kind of software. It's really very time consuming. So we should have some kind of automated system. If we want to upgrade it, it should be very smooth upgrade. It should be very user friendly to upgrade the system rather than facing a lot of challenges. But as we know that in each environment we have to upgrade so many different components, and if we want to upgrade those manually, it's pretty much effort. And there is when doing the things manually, there is a lot of chances that we can occur some kind of risk or some kind of issues. And yeah, production deployment. As in when I was working mostly in a maintenance team, the one issue I found, or one major challenge I face, that everything works very easily when I'm deploying in the develop environment or test environment. But when I go to production deployment, it always new problems all the time. So in deployment and test takes half an hour. I assume, okay, in production it may take 1 hour, but it never takes 1 hour. It makes few hours, 3 hours, 4 hours, because we always miss some steps which was already fixed by developer in the local environment, in the develop environment, and that kind of information was not passed to us through some kind of document or step or procedure. So as a operation team, we face always challenge. Solution is automate your deployment, remove all the manual steps so that we don't have to come across the new challenges or new issues when we are deploying in the production. Okay, so here we are talking about all the activities related to database. We have a tool called schema tools, and we club it with Gradle PLM, which is a kind of also one offering from our side. And with combination of these two, it's fantastic. It can upgrade, or it can you can implement your database related configuration, as well as you can deploy, or you can build your code, whatever you are writing. Another is 3DX installation tool. This is one approach to have symmetric setup in across the different environments. So whether you want to do in develop, test, stage, pre-prod, production, we must use some kind of automated tool. So this is one tool which I will show something. Repository, if we are when we are working with the code, we know that most of the libraries are available in Maven Central, but Dassault specific APIs or Dassault specific jars are not available. So those are available, we can have those available in our internal repository, and we can refer. So whenever our code is getting built, it needs those library, it can refer to those library, and it would be pretty easy. So we can get rid of a lot of manual things. SonarQube server. As a developer, when we write a code, before going for any kind of deployment, before I can say that my code package is ready, I have to test whether it is following the complete quality or not. There's two ways to do that. One is I can have some kind of standard check style implemented during the build process. Also, I can have some kind of quality gateway. So let's say I am having some minor kind of issues. I will allow, okay, this kind of issue could be 5, 6, or 7 times in my entire code repository. So I can put some kind of conditions using SonarQube, and whenever we are building a code, whenever we are making a code packet which I'm supposed to deploy in further environment, it will be tested, it will be checked at a lower environment, or initially when we are building it, so that we will not have some kind of surprise or any kind of surprise after it goes to the production. Because we faced many times this issue that once the code is in production, then we found, oh, we are not following the proper quality and it is causing some kind of performance issue, or this is not a standard way to do. So there's a lot of redundancy of the code. So we can get rid of those all kind of issues, or we must implement our system using some kind of quality gateway like SonarQube, so that we can avoid those kind of things at initial phase itself. And Jenkins deploy pipeline. So this pipeline provides some standard steps to deploy in different environment that I will just walk through for simple. So basically, this is what entire thing I was so far talking, that is continuous integration, continuous delivery. So we will have checkout step where the system will pull your code from the repository. It could be from Git, from Bitbucket. It will build your code packet using Gradle, TECHNIA schema tools, Artifactory, or we may go for some different solution like Maven, but here we are basically more focusing on the Gradle. So it build, then we check on quality gate using this SonarQube. We do have our internal SonarQube setup in TECHNIA, and then we can deploy. Of course, here we are using Jenkins. That's what I'm gonna walk through in next slide. So far, anyone is having any question, or I should proceed? Okay. A bit more about schema tool. This can runs with the Gradle. It can be used for building code and installing schema. Here schema means is doing some configuration change on the database whenever we are configuring our 3DX application. It helps maintaining the same setup in different environments. It contains some pre-tasks like related to database schema, and it support helps to automate the deployment. So if we are talking about this automation, we must have some kind of tools which can do all these kind of tasks, database related tasks in a standard way. So that's why we are using this schema tool or Gradle PLM tool. Another thing which I was talking about, the having the same kind of configuration in different environments. So we all might have heard a term called infrastructure as a service. Okay, so infrastructure is a broad term, or this infrastructure as a service is a broad term. So we would want to have this our entire infrastructure in kind of code, or in kind of repository, or in kind of standard process there where we don't have any kind of manual intervention. But if you don't have everything automated, but at least this server setup or this 3DX platform setup, we can have that in a repository, or we can have it in form of code. For example, I'm having a Tomcat setup in development environment and local environment, or it could be different kind of application server, HTTP server setup. So we can have different configuration in production, different configuration in test environment. But how would I track that when I'm changing the configuration? The only way is to track it if we are using some repository, if we are using Git. So the solution is that we should have all the configuration in repository, and we should deploy our configuration from the repository. We should not make any changes in infrastructure or in environment manually. If we do that and we run across a problem, we will spend many hours to identify that what kind of configuration changes we have done. Because of that, we are facing this kind of issue. And that's what we have included in our deployment process, that we are also able to deploy our configuration from repository to server or to environment. And the way we are doing is, for each environment, we are having some configuration properties file, we are having some templates, and for different environment, we are having different properties. From that properties, we are adding, just for example, JVM memory size. So in production and development environment, I may run with 2 GB of memory, but in production I may need 4 GB memory. So we can define it differently in a sum file, and from there we can pick the value for differently from production, differently from test environment, and we can deploy in the environment. And there is something written infra deploy stage. So in our pipeline, we are having a separate stage to ensure that whether every time we want to deploy infra, no. Because that is some change which we don't make very frequently. We may change that once in a month, or after first 3 deployment or 3 release are going without any changes, but 4th release we are making some infra related changes. So it is selectable. We can choose this if we want to. Automated 3DX installation, which I was talking about. So here we are using again Jenkins to install on a node. So we can define let's say these all are the tools which we generally install on a 3DX platform. So what are tools we want to install? We can have some, we are having some templates, and the Dassault provides with 3DX platform. They provide some thing called silent installation. So we are using that silent installation as a base, and we are using that capability to run this on our server where we want to make. Again, here you could see 2 things: Jenkins CI server and Jenkins node. So Jenkins CI server is your master server from where you are running all the deployment, and Jenkins node is your target server. So let's say it's my it could be my development server, it could be my test server where I want to run this installation. So having this kind of mechanism, we can easily run the standard way of the installation across different environment. The benefit is going to be, first thing, that all the environments are going to have the same structure. Second, it's going to be very symmetric and very easy, because we are not running anything manually. We don't run across any human error. Everything is happening through the script or through some kind of program. So it's easy to use. And when we talk about the upgrade, it's easy to upgrade. So let's say I'm running on one version, I want to upgrade to another version. So all I need to do is I need to point to the different version, and then it will run that particular version of the installation. Next is Jenkins deploy pipeline. This is what I was talking, that we are having a standard steps when we talk about the deployment. So those steps are like I'll start from stop services or clean workspace. So whenever before starting deployment, we want to clean the previous stages. We want to stop the services. Then we want to run a couple of steps related to deployment, like installing the schema, installing the unified schema. I think someone was talking about the installing unified schema also. So that is a separate step. And deployment of 3D space, deployment of integration. This is two different way of applications that are provided in a 3D experience. So one with a case system, one with a no case system, and run some post deploy scripts and start services. So this is some standard pipeline where we can use a configuration file so that it can be customized, it can be configured differently for different environments. And of course, there is a way to choose that what all steps we want to run. So let's say I'm just doing one hot fix deployment. I'm not doing the deploying the full thing. I'm just doing the hot fix. I just need to put 2 files. Then I may not have to run this all the things. I may have some selectable option. I may choose some only the required step, and I can proceed with the deployment. Here, these are the steps where we are using this schema tools, because we have to deal with a database, and to deal with the database, we are using schema tools. And this is our pipeline. So we have all the stage. We can select couple of stages which we want to deploy, and then Jenkins servers is responsible to communicate with the Git, with Selenium, with JUnit, with SonarQube, with PowerShell, and it deployed to the server. So everything is abstract from as a maintenance team member. They all have to do. They just have to do one click to deploy that. They don't have to do a lot of manual activities, because all the manual activities related to pre-deployment, related to post-deployment would be taken by the system itself. And since developer understand the system very well, so they can ensure that whatever they are pushing to the repository is correct for that particular environment. And if there is an issue, there is a flaw, that would be catched during the development, during the deployment in development environment, or during the deployment in the QA environment or test environment. So that is how we will avoid the last time surprises which we faced during in our production deployment. Some screenshots from existing implementation, multi-branch build. I would like to highlight here also. The Jenkins is having, if we understand that for when we are working as a development or different features, different releases. So at a time we deal with 4 to 5 different branches. So we have to build them. We have to ensure that whenever any changes are happening, it should get built and it should have the right code package, right artifactory. So it will help us that whenever we are creating a new branch, or whenever we are deleting any branch, or whenever we are committing any code to the branch, it takes it automatically, it identify automatically, and it triggers the build automatically. So at any point of time, we don't have to worry, or we don't have to spend time about building and maintaining multiple repositories or multiple branches. Status of all at one page. In this screen, we can see that we have so many environments. On single page, we can see that where is pass, where is fail, and when it was get deployed last time. Easy to maintain. Stages for build. I've been using this build word a couple of times. I hope most of you guys understand, but just giving an example, explaining that build means from our code, from the DSO files, our custom code, and some configuration we are making, clubbing everything and making one set. So that is called build. And when we are making a build or making a code, final code packet which can be deployed to different environment, these are the steps which we follow. So notify, build. At the time of build, we can have check style implementation, so that we can enforce the developer to follow the standards or coding standard which we want to have in our organization, and that is very much important or useful. SonarQube analysis. So after once they are done with their code build, we can check at the quality gate whether this code is up to the mark or not. We can run some automated test case, like either JUnit test case, we can have Selenium test case, we can have for user UI test, we can have some different framework like Jasmine framework, we can implement that and we can run those tests, and that is how we can control the quality. Because overall idea to have this practice is to have a good quality software or good quality software application when we are, or good quality of code when we are deploying to the production. That's what is our idea. So we should have more stages for testing, or different stages for different kind of testing at the time of build, and then we can archive, and then we can have that as a code packet to deploy in further environments. This is how we can get notification. So you can read in a message that the deployment of develop is successfully deployed on dev01. So that means whoever wants to get notification, everyone is not getting email. The problem with email is whether I want to get that email or not, or maybe I may want to have that kind of email for a short term when I'm working on some in that team for some small duration. Let's say for 2 weeks I'm just doing some responsible for testing as a business user, and I want to get notification for 2 weeks for one environment, not for all the environments. If we will have the mail kind of setup, then once you are asked, okay, I want to have mail, you will get 10 mail or 20 mail every day for every deployment. Here we can choose by subscribing the channel. If you want to get notification, you can get. If you don't want, you can just unsubscribe it, because this Microsoft Teams platform is very much flexible. It provide a lot of plugins. So we are having some plugins connector so that we can connect it with our Jenkins server, and we can get notification on the deployment. Now we talk about the benefit. So if we think that what kind of limitations we faced, similarly we are trying to cover up more of the challenges, like having different environment or different configuration. So using this standard installation tool, we can get rid of that. Database related configuration, we can use this schema tools, PLM tools. To getting different library, we can use this TECHNIA Maven. For code quality, we can have a Sonar Cube, and new environment can be set up easily. Fix spec upgrade can be done easily because installation is automated, and Jenkins is open source, so this is free of cost. So if you are using this Jenkins for having this kind of CI/CD setup, we don't have to invest a lot. It's just a one-time implementation because it's open source and free, and notification can be managed easily because everyone is using a Microsoft Team nowadays, so it can be easily configurable.